Hey guys, I figured I'd just make a little video and show you guys what the problem is here. So I have DS-095 servos installed in the flaps of this model. I've been doing quite a bit of experimentation, you can see. So I have a probe for the servo signal, servo voltage. I've also got a cap in there on the power supply, just in case there was some real fast transient events I didn't see. I've got an active current probe on the servo current. I'm powering everything from a lab supply right now that can deliver 10 amps, so we're not running into the current limit situation. For reference, the purple signal on the oscilloscope is the servo signal itself. You can see the width is about 1.3 milliseconds. The blue trace is the servo voltage. At this point, it's a bit over 6 volts. The yellow trace is the current into the servo. And here, my bench supply is a little out of calibration. You can see I've got 6.45 programmed, but the actual voltage is 6.6. So the multimeter gives you the actual voltage into the receiver. So there's wiring harness losses associated with it too. So here's the problem. Let me see if I can get everything in the frame. When I actuate the flaps, if I do it slowly, it's okay, but if I snap the flaps back, I can induce an oscillation. Now let me see if I can capture that on the scope for you guys. And I can damp the flap out by putting my hand on it and forcing it to its neutral position. Looking at the waveforms, there's a definite correlation between the servo pulses being sent and you can see the blue trace, the voltage falls on the servo power, and the current goes up, peaking a bit over an amp, RMS of about 0.9 amps. So it is a significant amount of power. So I'm not really sure what this is. I think that the mechanical oscillation might be on the same frequency as the servo pulses, which are happening at 45 hertz. So the only way that I was able to get this to become stable is to lower the power supply voltage. I found that about 5 volts or anything below 5 volts would be safe. Let's try 5.3 and see if we can induce it. So I'm just going to ping this. Okay, it's definitely oscillating. But when I was doing it earlier, 5 volts was pretty safe. Yeah, it's starting to oscillate again. Let's change it. Okay, so it's oscillating, but it damps out, which is a good sign, but it means we need to go even lower in voltage. So here's 4 volts, and the oscillation damps really rapidly. On the other flap here, I'm not having any sort of the same issues, even though it feels like when the flaps are unpowered that the amount of kind of play in the linkage system is identical. So if I lower it further, I'm guessing there's a 3.3 regulator on the microcontroller, so we'll put a 3.7 lower shelf on our test voltages here. So now we don't have any issues. I mean, it's still not behaving the same way as the opposite side, where you can hear the servo resisting. This, if you move it slow, you hear the same thing. And the backlash that exists is in the gear train of these servos. The servos have been used. But we don't have the oscillation problem anymore. So it seems like in the control circuit for the DS-095, the gains are set too high to allow voltage, higher than 4 volts-ish, it seems, to be safe. And I realized that you give up settling time performance by having those gains set at a safer margin. But from the looks of it, if your intended operating voltage was 5 volts and you can only run it at 4, your gain figures are 25% too high to ensure stability. So I'm not sure how to change that. I'm going to look into using the programmer here and see if we can manipulate those gains or if there's anything we can do.